Now let's see how this particular code works. Okay, so here what we have is we are using a pseudo instruction. Okay, so basically we are storing the address marked by this particular label into the register R0. What happens here is that this is again a pseudo instruction. We are storing a very large 32-bit value into register R1, and that value is 0x12345678. Okay, in this instruction what we are doing is nothing but to this particular read write memory area we are storing this 32-bit data. Okay, so the new value stored in this particular memory location will be 12345678. Why exactly I am doing all this? Because initial value of read write memory area will always be 0 irrespective of whatever you write. You will always have to follow this approach in order to store a valid value in the memory location, okay, for read write memory section. And now you can carry on with your actual swapping instructions. And before that we need one register also in order to hold some 32-bit data. Swap a byte of data between R3, R2 and content of R0. This is what is written. This is same as RD, RM and RN content. Okay, so what should happen? RM, whatever data is there, that is content of R2, will now be loaded to the memory location pointed by R0. Okay, and what we have in RN, what is RN content? That is nothing but content of R0 will now be shifted to R3, okay, which is nothing but your RD. Fine, this is what will happen. Let's see how and what should actually happen here. So that is nothing but what exactly is R2 content? R2 content is nothing but 0x8 all zeros and 4, but only a byte of that, that is 04 will be updated in the lowest byte of R0. And what happens to R3? What value will be loaded to R3? Out of 1, 2, 3, 4, 5, 6, 7, 8, the lowest byte, that is 78, will be loaded into R3. And next instruction that we have very minor changes because it's exact same instruction, just we are trying to load 32-bit data instead of 8-bit data. Okay, so 4000 is our memory location. Okay, initially all values are 0. 1, 2, 3, 4 32-bit data now we have loaded into register R1. We are storing this 32-bit data in the memory location 4000 as shown here. Now we are loading one more 32-bit data into register R2. Okay, so here actual swap instruction starts. We want to swap a byte of data between these three registers and memory address. Okay, so R2, what data it holds? 8 all zeros and 4. What do you mean by just a byte? That is the least significant byte 04 should now replace this particular content. Okay, because this is nothing but your R0. Okay, and then what should happen is R3, which is initially 0, should get updated with the value 78, that this should come here. So let's see that happening. Okay, so this is 78 and this is 04 as expected. Okay, so next what should happen is here instead of just swapping byte of data, we are swapping entire 32 bits. So R2 content, entire data, that is 8 all zeros 4, should now be placed in this particular location, and R0, whatever content is there, that is this particular value, should now be placed in register R3. Let's see that happening. Okay, as you can see, the entire content 8 all zeros and 4 got placed here, and the previous value which was there in the memory location pointed by R0 is now placed here. You can see instead of 1, 2, 3, 4, 5, 6, 7, 8, it's 1, 2, 3, 4, 5, 6, 0, 4, because in the last step only we had modified the lowest memory location content. Okay, so that's all.